Nats.io Community Office Hours. My name's Jeremy, and this is Nate. Nate just recently joined the Nats team. He's going to be helping me out with our office hours, so this is going to be really, really fun. But for those of you who are just joining us for maybe the first time, this is a place where we're just going to chat about anything Nats related. And so if you have any questions, you can jump into the chat. We're doing this all on riverside.fm now. So if you're joining us on socials like on YouTube or Twitch, LinkedIn, X, you can watch all of this here. But as far as the community Q&A goes, we're going to be watching all of the channels to try to pull stuff in. But you're probably going to get a lot of your questions answered if you jump into Riverside. So I will actually, you know what? I realize I don't even have the link. So for those of us who are joining us on socials, I will throw up a link to our Riverside thing, I guess up here. Here, let me go ahead and just paste it in. It's going to be Riverside FM, Nats.io Community Office Hours, like this. And then you can join us that way. And so also you can go to Synadia.com, and there is a banner at the top to join this office hours if you want to join us on Riverside as well, and we'll send out the links there. So we'll make this more accessible in the future, but it looks like we already have some people jumping in. So feel free to jump into chat and say hi. Tell us where you're from. We'd love to chat more. Tell us how the stream is going. How does the stream look, everybody? All right, cool. Looking and sounding good. That's great to know. All right, thanks for joining us, Ryan, Robin, Nate. Obviously, you're here with us. Nate, you want to tell us a little bit about yourself, and then we could jump into our agenda today, and then even just start jumping in and answering some questions.
Yeah, absolutely. And I was kicking the tires in the chat, going to a couple platforms, making sure we see it all there. But yeah, my name's Nate, like Jeremy said. I've been making websites and developing web applications for about 20 years now. And yeah, I've been a programmer since a really young age. Got one of my early jobs in like the early days of HTML, but just really have loved the development and computer science ever since then. And I'm 1 month in at Synadia now. So Jeremy just hired me, and yeah, just closed out last week, I think was my first month. And it's been a blast so far, and I'm enjoying really digging in on distributed systems and on a lot of the messaging stuff and patterns that I got into a lot more as an architect in the web space, using things like Kafka in the last 5 years. But really, really excited and just blown away by the technology of Nats already. I'm not a long-time user myself, but it's been so cool to jump in and kick the tires and work through the docs and do stuff in the CLI. And the power of this technology is just very apparent, and it's been really, really fun.
Yeah, and we have some big plans. It's awesome talking with Nate and kind of figuring out what's next for our content strategy. Obviously, we're going to be doing these more consistently. So if I'm sick or out or traveling, we'll have more consistent office hours, which I think will be great. We'll be bringing more Synadians in, and we'll also be spinning up new things like podcasts and more content coming to you guys from YouTube, tutorials, docs, things like that. So I'm really looking forward to it. And we could also use everybody's feedback here. This is a sounding board and a way for the community to kind of engage with us at a regular cadence. So feel free to literally ask anything, our thoughts, or whether or not we're choosing to invest in one area or another. We really want to make sure that there's a tight feedback loop between the teams working on Nats and working around Nats, as well as that feedback is coming very, very quickly from the community. So, all right, I'm going to jump into just a couple updates, like what happened this week with Nats, and also maybe jump into a couple like blog posts that we found around the community, stuff that's in our backlog that we've been wanting to read. And we could read through them, chat about them a little bit, and then we could jump into any sort of live Q&A. Like I said, Nate will be watching YouTube chat, and a couple other socials, and just kind of paste chat comments into our agenda. So let me go ahead and pull up my screen again, and we'll get started. So one of the first things that happened, or this actually happened last week, but we did post a brand new video all about embedding a Nats server. And so if you haven't gotten a chance to watch that, I'm not going to play it for you, but we did release a new video on what it's like to embed a Nats server, which I think is a really cool pattern for Nats. And you could watch, you can watch all of my opinions there. But the long and short of it is, you can take a NAT server if you're writing a Go program, and you could embed it into directly into your application, and that makes for a really nice kind of set of properties. You can not only can you like use it for things like distributed, or sorry, not a distributed, but a modular monolith where you might be writing microservices, but you want them all to be kind of deployable in one single unit. But you could also kind of mix this with like the concept of leaf nodes and NATs, which I think can be a really powerful pattern in general, because you can then have a completely embedded NAT server. You don't have to use any sort of network interface for all that stuff to communicate with it. But then you could also sync that data up to like a cloud service. And so, thinking about like offline first desktop apps, it can be a really neat pattern for that. So I'd say if you haven't given this a chance to watch it, this is a really neat one. And it seems like it's been pretty popular with folks to figure out how to embed a NAT server. And if you have any kind of, any kind of opinions on videos that you'd like to see, just drop them in the comments here. Let us know, and we'd love to kind of consider, what that could look like. We do have our own backlog of stuff that we'd like to cover, but if there's any community, thoughts on videos they'd like to see in the future, yeah, do let me know. I'd love to kind of figure out, how we can accommodate that. Okay, let's see here. It looks like we are live on YouTube. Great. Just wanted to check that out. Let's go on to kind of the next piece of agenda, which is we have a new blog post on rethinking microservices. And this was a guest blog post. We're going to be having a lot more guest blog posts on our blog. But this one might be interesting to read. The perspective I like from this one is it's somebody coming from like more of a .NET perspective and using our .NET libraries. And I think our .NET libraries have we've invested a little bit more effort into them, and I think they've really come a long way. And I know we just recently did kind of a switchover release for our C# libraries as well. So yeah, this was also a good one to check out, like what a microservices architecture could look like in from the lens of like .NET, and what kind of things that you would normally use inside of a microservice architecture that you could totally replace just using NATs, which I think is really neat. So if you are interested in working with .NET or learning more just about like another way to do microservices and NATs, this is a really good blog post to check out. I would highly recommend it. I'm not going to necessarily read through this, but I'm going to jump through a couple other things that I do want to kind of read. All right, before we move on, Ryan has and I'm going to try to pull this up on the text and see what it looks like. It's a big question, but let's see what. Okay, cool. That doesn't look too bad. Ryan said, great video on embedding. Thinking of using embedded NATs with Jetstream and KB to store a desktop app. Will there be multiple instances of the application running on a local network? And it got a little bit cut off. So let me just read the rest of it. There will be an application that's open to customers that will have a subset of the data that can be updated via CRUD operations. Any suggestions on supporting this configuration? So you can use leaf nodes if you want to sync between those, but it's kind of worth thinking about your architecture in general of whether you want this like distributed kind of sync architecture where you have like two independent like NAT servers that are syncing between each other. And that's where like a leaf node connection could come in handy, because like leaf nodes don't necessarily like assume any sort of hierarchy. Let's say NATs server, leaf node. The interesting thing about NAT servers and leaf nodes in general is that like leaf nodes don't assume any sort of hierarchy. Like while the most common configuration, leaf node communication. Well, the most common configuration for a leaf node would probably be like hub and spoke, right? Where you have a centralized NAT server, and then you have these kind of leaf nodes that are kind of around the NAT server. And like the reason why this is most common, I think, is because NAT does a lot of really great things to support the edge, and you kind of have this leaf node architecture that will basically sync to a hub, right? And that's one way that you can do it, but it's not the only way that you need to do it, right? Leaf nodes are really like like I said, they don't really assume any sort of hierarchy. So you could literally just leaf node two systems together and have them sync. And so that's one way that you can do it. It can get a little bit tricky though, because you have to kind of, if you're using like decentralized auth, you're going to have to like, map accounts and also kind of figure out how you want to map your streams between those two. Like, is it that you want to have, a stream that ends up on both sides and like looks the same and it's kind of like a mirror? Well, you can't really use mirrors because mirrors are only one way. So you kind of have to like choose, do I want to source this way and remap the subject, and then source it this way and remap the subject? So it can be a little bit tricky, but you can absolutely do it. So I would recommend checking out our documentation on leaf nodes and how you can kind of leaf node two things together and create that connection, and they can operate independently. So I think that's the question that you're mostly asking, is you have like these two things that you want to embed and you want them to be able to synchronize data. You can either go centralized with it, or you can go kind of decentralized and have these two things share data. But it also just gets a bit more complex when you're like, well, who owns that data? What happens when somebody's, not acting correctly, right? And so it's all worth kind of thinking through, but the long and short of it is that leaf nodes, leaf nodes can act pretty like independently. They're independent agents in a lot of ways. And so I'm thinking in your example, Ryan, that like you could have each desktop be like a different leaf node, and they could either connect directly to each other or connect to some sort of hub for sync. So I think that's what I'm this. Yep. All right, so Renzi asks a question. He says, have you done any videos on distributed locks yet? I did a small project this spring and found a good issue on the subject in Golang client repo. Perhaps you've covered this before. Yes, I have covered it. It's not a dedicated video. We probably should do more of a dedicated video on it, but we jumped in. Let me just go to YouTube and I'll search. Let's go to Synadia. And we'll just pull up, it's one of the Jetstream videos that covers distributed locks. I believe it's the one I did on KV. So I think
I'm gonna go
fascinating alternative to Redis, wherever it is. But yeah, it is on this channel. Synadia Redis, let's say. There we go. So when I cover this Jetstream KV, I do cover like the distributed lock pattern. I think I also, I do like a little leader election example here. And so but the long and short of it is, you could watch it, in detail on this video. We also do have the new per subject discard policy, like John Noel mentions. So you can do this on a stream, or you can do this on a KV. In the case of a KV, the long and short of it is we have a couple like KV operations. I'm going to throw it over here. KV operations. And this is assuming like once you have a key value store created, these are the operations that it gives you to kind of like manipulate keys, right? So you have your puts and you have your gets, and those are like pretty straightforward. You can put values into the key value store at a particular key. You can get values at a particular key. But then we have what are like our more optimistic concurrency control like primitives, which is create and update. And what create and update will do is not only do they require a subject, so these guys need a subject, they need a payload, right? All of these things besides get. They need a subject and payload, so they know what subject to put it in, what payload to put it in. But then this also needs a revision ID. And so there's a global kind of counter to all the values that are put into the key value store. So every time you put something in the key value store, we basically take the we take the revision, and we just create we put a +1 on it, right? My brain's not working quite well today. We put a +1 on it every time you put something in the key value store, right? And so what create and update does is it validates that you know what the latest revision is. And so what you do is when you do a create or an update, you just put in that last revision, and it will fail if that last revision isn't matching with what the key value store knows, which basically means like, hey, you're not the most up to date. And so what this could mean is you can use this kind of as a pseudo distributed lock, where you might have a client that's talking to a KV store over here, KV and client, and it's going to try and grab a lock, right? And so it's going to go ahead and say, I want to create, I'm going to do a create call on, foo.bar. This subject can literally be whatever you want. It's whatever the lock is. And if it can create, that's great. It's gotten a lease, essentially. All right. What you want to do is you want to configure this key value store to have a TTL of like, let's say, 5 seconds. Okay. So now it's the client's responsibility to send an update every, let's say 3 seconds. Update every 3. And that way, this client can send that update because it knows that it owns the lock. All the clients have to abide by these rules. So if a client wants to grab a lock, they have to also try to send a create. But the problem is they can't send a create because the key already exists. And so the server is actually just going to send back like, nah, you can't do that. Please wait. So this is one way to kind of like model with a KV, the kind of distributed lock pattern. Oh, I just totally destroyed that arrow. This is one way to kind of model the distributed lock pattern. I think it's actually really, really nice and really elegant. And I kind of go over how to implement that in the video that I just looked over. So that's one way to kind of go about doing it. There's other ways to do it as well. This is kind of like a lock lease pattern. But yeah, one of the other kind of interesting things is that in NATS 2.11, we're going to have per key TTLs. And so it's going to make like building a lock and having it be more ad hoc and not so static on a key value store. It's going to make that just a lot easier to deal with. So I think this is a cool pattern, and you could use this really, really well. I hope that kind of explains things.
And Jean Noel dropped a blog post as well on infinite message deduplication and jet streams. So
yeah, let me pull that up. I'm gonna copy and paste this over here. Oh yeah, so sorry for the white. It's burning my retinas. But yeah, so Jean-Noel back in 2022 talked also about infinite message deduplication, and there's some similar primitives that kind of like make all of this work. And honestly, it's like we have all these primitives come together to like make things like key value store work in general. So it would be fun to kind of cover more in depth what the key value kind of optimistic concurrency control affords us, because like this is just one expression of the pattern, but there's like so many different ways and different like little things that you can do with it once you know how the primitives work, that it would be cool. It would be a cool thing to kind of cover. So I hope that answers your question, Serenzi. And I'm curious, you should let me know in the chat like what you found in the Golang client that wasn't necessarily working for you, because I'd love to kind of check that out. Again, if you're just joining us, feel free to jump in, ask questions. We're also monitoring our chat for live stream. It looks like we did get one question coming from YouTube, so I'm going to go ahead and pull that in. Let's see. Whoops. It's going to let me copy it. Let's see. There we go. Okay, I should be coding asks, hi, Jeremy, can you make a video in the future about accounts and multi-tenancy? I want to distribute conflicts between accounts using KVs, but configuring the permissions is a bit underdocumented. Yeah, I agree with this. I think I have a video on like the multi-tenancy and like setting it up, but I think we should do like a video on specifically the permissions for like KV and streams and object store and stuff like that, because there's a lot of operations that you kind of have to know. And I like we've talked about improving this in the future, but just for those of you who don't know, when you're configuring permissions for things, it's all subject based. So it's really simple when you have things like, oh, I want somebody to be able to, I want to allow subscribe to foo.bar. and I want to, deny publishes to bat.baz, right? It's easy when you have like, all these subjects that you created and they're all simple. But when you have like a KV store, you have to do stuff like, oh, I need to allow them to, publish to like, I don't know, it's $, JS dot, whoops, $, js.kv, blah, 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 blah. There's all these kind of incantations that you essentially have to put together. And so I think we should one, yes, I think I should have a video that kind of covers some of the basics here so you can kind of know. But we also just need to do a better job of like outlining it in the documentation. And also in the future, and something we've talked about is like, can we just make this easier? If there's another construct that's like, yes, allow them to publish to a KV or allow them to watch a KV without saying, here's the 3 or 4 subjects that you need in order to get it. So I agree. There's definitely some improvement that we could have there, and I'll note that down to make a video on it because I think we can probably make it a short video too. It doesn't have to be like super in depth, but we can cover a lot in a short amount of time.
And I am noting down all these
on YouTube. Sorry. Go ahead, Nate.
Yeah, I was just saying I'm noting down all these video suggestions as well. So Jeremy, don't worry. I'll have a summary, and also please keep throwing them in chat. We love throwing these into kind of a backlog and building up more ideas for the content. So
nice, yeah. And I know it looks like our YouTube is going a little bit slow. At least on my end, it's going slow. So we're like a couple minutes behind. But I'm going to pull up some questions that came up, especially from Yordis. Yordis, thanks for joining us on YouTube. I'm going to pull some of these up. If I can use my computer correctly. Just 1 second. I needed a quick copy to clipboard screenshot tool. Yordis says, I'd love to see a video about basic job processing tool using a to-do list pattern. Interesting. I'm curious to know what that looks like, because I know I did a video not too long ago where I did go over a job queue. So if you can elaborate a little bit on what you mean by to-do list pattern, maybe I'm missing something. Yorda says, related to multi-tenancy, definitely still trying to figure out the best practices in general. Yeah, and I actually get this question a lot, and it might be a good topic to go over even a little bit right now, because it's a very common topic. If we don't have a bunch of questions flowing in at the moment, one thing I can cover is multi-tenancy best practices, specifically how to use accounts, because I get this question a lot, especially people who just even are just using multi-tenancy already. They're live in production, and there's some ways to think about it that I think can be really, really helpful. So I'm going to hop back over to Riverside, see if there's any chat messages. Okay, so Renzi got back to me, said, I got it working with the project I was looking into. GNMIC was just using a distributed locking interface toward etcd. I got the locking to work, but unfortunately some other infrastructure communication did not have any good interface, so I had to put it on the back burner. Yeah, that's something that you can kind of unfortunately run into, that you kind of require NAT server or NATS protocol. One other kind of option would be to create some sort of HTTP interface for it. I think that there's a pretty good interface on console for a distributed lock over HTTP, and I think you could probably model that pretty well. You just create a little service for it, right? But yeah, that's something that you can definitely run into. Okay, so the question I get a lot is how should we use accounts? And just to kind of explain a little bit about multi-tenancy and how it works in general, is that there's this hierarchy. We have, at the very top, we have an operator, and that operator can represent an organization or an entity. It's somebody who's operating the NATS cluster. So it's kind of the highest order of ownership inside of a particular NATS cluster. That said, NATS clusters can be leaf noded together, so you can have these multiple operators interacting with each other, which is pretty cool. Underneath that, you have accounts. I'm going to say account B and account A. An accounts kind of represents tenants in a system. If you were to think about this in terms of an organization, if the operator is like the, I don't know, the DevOps team, or you just call it the organization in general, then the accounts might be like teams or business units. That's the way that I like to think about it. I like to try to map the tenants in most applications, like by default, to something that's like tied to humans at the end of the day. And the reason I do that is because this whole model of multi-tenancy inside of NATS is a delegated model. Basically, the operator is delegating a certain amount of responsibility to the account. They're saying, hey, here's how many connections you can have. Here's how many, like, here's what your bandwidth is. Here's how much stream stuff, or whether you can do jet stream. They're saying you can do all this stuff, and here's your parameters, but then go wild after that. And so, like, the account exists in their own completely isolated namespace from this other account, right? And so they can kind of go hog wild doing whatever they want to do. Account A could be really strict about permissions. And account B could be like, I don't want to use any permissions. And that's, in some cases that could be totally fine, because these accounts are isolated from each other. And so if you're thinking about the way this works in terms of delegation. Here, let me throw some users in here. Users are kind of our smallest kind of entity here, and those are credentials that clients use to connect, right? But if you think about it in this way, it wouldn't really make sense to say, like, create one account per microservice, because then you're going to have like thousands and thousands and thousands of accounts that you have to manage. And honestly, that's one mistake that I think people make when they start using this model, is that they'll be like, well, if these are isolated, then I get easy security by being able to just create one account per like service, or one account per application, or whatever. And that ends up just being a lot harder to deal with, because inevitably those things will likely have to share data with each other. And especially if they're close together or they interop with each other pretty tightly, they're going to have to share a lot of data with each other. And the way that you share data between accounts is using imports and exports. But imports and exports have to be explicit. They're kind of, tricky. They can be tricky to set up, stuff like that. So it's not necessarily meant for this like large scale sharing. Instead, you want to be able to kind of have every thing that wants to interact heavily with each other kind of floating inside of an account, and using permissions to kind of lock those down if you need to. And so that's one way that you can consider going about it. I like to try to keep the number of accounts that I'm managing like smaller. But I like to start with thinking about, okay, what are the different teams or business units that I'd like to have these separated by or segregated by? And then maybe there's like certain application or technical elements that I want to separate things. Maybe I have, customers that are needing to have access, and so it's an account per customer, things like that. But I like to default to a smaller number of accounts, because I think that makes for a much more like sustainable way to go about it. So Yordis, I hope that answers, some of the best practices types of things. I know this is a question that I generally get a lot. And so that's something hopefully that was useful. Yordis also asks, who would be the operator? So like in our case, like let's look at Synadia Cloud for an example. The operator for Synadia Cloud is us. It's Synadia, right? But the accounts in Synadia Cloud, we delegate responsibility to, when you sign up for Synadia Cloud, you get an account, and we say you can do whatever you want in that account, right? You can create whatever users you want, as long as you're, abiding with our limits, and that's how we bill, right? We give you limits and you pay for those limits. Then you're good, right? And you're isolated from everybody else's account. Now you can share between accounts, but that's going to be a lot. You sharing data with like either one of your other accounts, or even like imagine you want to share data with me and my account in Synadia Cloud. That's going to be a rarer occurrence than like you sharing data between your service A and your service B, right? And so so that's kind of the way that I think about it, which is like you want to try to keep related things inside of a single account. And then unrelated things that may share data or share data in a very limited sense, a very structured sense, maybe should be separated out into accounts. And I think when you're working in an organization, it tends to be like teams or business units that tend to like have those properties.
I
Uh,
feel like this over sandboxing is a common architectural pitfall too, because it's easy
yeah,
when you're architecting a system and thinking about it at rest to see things as kind of, oh, well, this is free security, free sandboxing.
yeah,
But then what you don't see, especially in initial architecting, is, in motion day to day when the systems are actively in use, what extra maintenance does that actually incorporate? Things appear free on the architecture diagram depending on which part we're focusing on at that point. It might be free in persistence or latency or overhead. But then when the system starts running and you have to do more processes, do more backup processes, whatever, it comes into that day to day maintenance. I feel like that's where you feel the pain and complexity that can grow.
yeah, all of these connections can have like a cost to it. Like not
Right.
necessarily a runtime cost, maybe sometimes, but like but there's a cost in like maintaining it. It's like something that's floating out in the world, right? It's the same thing for like streams in a lot of ways. Like people come to us and a lot of times like from a Kafka lens, they're like because they want to upfront kind of like plan all of their stuff because that's what you do in Kafka land. But like they'll ask like I have all of this stuff, like should I make like 1,000 streams? And we're like, you can make 1,000 streams, but then you have to manage 1,000 streams, and like that's a thing that's floating out in the world, right? That's like that you're going to have to maintain. And so, like, what if you just created one stream and put all of your subjects into it, and then, any clients that need to consume from that stream can easily. I don't know why I drew boxes for streams. I usually draw triangles for streams or diamonds for streams. You have this one stream, and then for each of your clients, you can just filter them, right? And that's kind of like the difference of philosophy for Nats is that like you want to try to consolidate stuff into like stuff that makes sense, but put a bunch of stuff in one big stream, it's going to be okay. And so like that's one way to kind of think about it as well, where it's like you're now reducing the amount of moving pieces instead of saying, oh, we're going to have 1,000 streams. And it's the same thing for accounts. Same thing. Just the properties of an account is like it requires some management. It requires some overhead of management. And so like, do you really want to manage 1,000 of them, or do you want to manage just a handful of them? So. Yep. The other thing is like accounts, they also live on the server, right? Accounts get pushed to a server and they're managed on a server. So every time you update account, you have to push it. The cool thing about users is because they are using the trust chain, they don't live on the server. You don't have to push them. You just mint them, right? You could just create them out of thin air, and it uses cryptography, and you just make a new user, and that's kind of nice. So like users have a lot less overhead in maintenance than like an account does, for instance, because they're ephemeral in a sense. Um, Wayne coming in with the memes on YouTube saying you can account on it. Yeah, you can. So Yordis also asks from YouTube, like, what would it look like in this circumstance if I had different environments? So like would I provision accounts for a given customer per environment? That just depends, right? Like sometimes it depends what an environment means to you, because like an environment could mean a whole new cluster, or an environment could just mean a whole new account. Like if you were to jump on Synadia Cloud, you might have an account for prod, an account for dev and stuff like that. But like maybe if you're inside an organization, you're operating separate NATS clusters. So it's all just going to depend, and you can model it however you'd like. Depending, like it's kind of funny because, and Nate, I'm sure you get this. Like there's companies that they'll operate completely different infrastructure for their different environments, but then like there's also a bunch of companies that will use a SaaS like provider, and they'll model their three environments, but it's all on the same infrastructure, right? And so it's like there's going to be different like philosophies for what environment means in different organizations. That's just the reality of it, and a lot of it's dictated by the security team at the end of the day.
Yes. Usually that's the definition most impactful to the implementation.
Yep. Okay. Yeah, so like production versus development, like you could have it on all one cluster, you could have it on separate clusters. It's just there's trade-offs involved with all of those, right? If it all goes down, then it's down. So that's one thing that you have to think about as well. Okay, we got a couple more questions. Ryan asks, if Synadia Cloud is the operator and customers have their own account, how are they able to create additional accounts to separate things under? Or am I misunderstanding the hierarchy? You're not misunderstanding the hierarchy. So the cool thing is, like so the operator is the only one who can create accounts, right? But the operator could provide functionality for you to create accounts, and that's exactly what Synadia Cloud does. Let me try to jump into Synadia Cloud real quick and show you. So Synadia Cloud is like basically like our dog fooding of the whole like multi-tenancy and account system. Hopefully it'll just let me sign in with GitHub. Okay, there we go. Okay, so like that's so funny. I still have a bunch of stuff running in the background. I have like 85 connections on my Widget Co account, right? But I can go ahead and create like another account and, let's call this like, I don't know, office hours example. And I can choose like, it looks like I'm maxed out on a lot of my stuff, but I'm going to try to save this and see if I can. Okay, so now I have an office hours example account, and now these two are completely separated from each other. I can share stuff between them. Like I could go into sharing, and I could export a service, foobar, foo.bar, dot greater than, and I can share this with my Widget Co account. And that's creating an import and an export, right? And it's kind of like creating a link between those two accounts. But it's that's a little cumbersome if you want to do that for everything. But yeah, the way that kind of works is like we, as Synadia Cloud, we will help like provision accounts for you. Like provision an account, hand it over to you and say, hey, we've delegated you the responsibility to create an account. Here are your account keys, essentially. And then you can go and create whatever users you want inside of that account, foobar, and you can just go hog wild. Like we don't even look at this account. We don't look at the users you create. We don't look at that stuff. It's all your stuff. And so that's kind of the cool thing. And it's also cool because like you don't have to ask us to create a user. Like you have all the keys to create a user. You could actually download your account keys and you can like just mint users like on your computer. Like you don't have to do it inside of Synadia Cloud. That's a really neat thing about this kind of model is that it is kind of like very delegated, decentralized in a way. So we delegate what we need to delegate to you, and we know what we need to know, but what we don't need to know, we don't need to know. So great question, Ryan. Mitch asks, what if the cluster spoke topology is using auth callout? Can each be a spoke for a different account? So let's take away the auth callout thing just for a second. Let me pull this back up. Can I just put this up in 20 seconds? Okay. So if you have a cluster spoke topology and you're using auth callout, can each spoke be a different account? And the answer is yes, even if you're not using auth callout, like even if you're using decentralized auth. So let me kind of show that to you because we already have a little hub and spoke here. So assuming over here, this is the hub. And all of these are spokes. All of these leaf nodes, they have to connect in, or they don't have to, but like if this is using like decentralized auth, they have to connect in with a credential, right? And this credential is kind of what dictates what goes over the wire. So if you have like a user that has permissions to do a sub on foobar, that's like what's going to be allowed to go over the wire essentially. And so you can kind of think of your user permissions for your leaf nodes as a way to control what data moves through this link. And so the other thing that you can do when you're creating a leaf node connection is figure out like what account you map that to. And so yeah, the short of it is you can have an operator here that has all these accounts, and each of these can connect into a different account on the hub. And the cool part is, because this is a leaf node, these things also have their own security model. So these can also use decentralized auth, or they could just use no auth, or they could use username and password. Sometimes it's simpler when like this is maybe in the cloud and it's using decentralized auth, and these are maybe out in the edge and they're like on a box somewhere, and all these other things are connecting in. Maybe it's simpler to use like username and password here. or simpler to use N keys, or something that's not as complex as the decentralized auth. So that's one thing to kind of think through if you're modeling something like this. But you can have different security domains for each of these individual systems. But yeah, to connect these in, you'll use a user credential. That user credential is associated with an account. Even when you're creating these leaf node connections, you can decide on the leaf node which account you want to map all that traffic onto, if that makes sense. And the weird part is you could also have multiple leaf node connections. So you could be like, oh, well, then connect to this guy and like map it onto this account, create this guy and map it on this account. Now you kind of have this weird like mesh or daisy chain. And like there are architectures that make sense for this. Sometimes when you're going from cloud to factory to processing center, like you might need to have weird daisy chains like this. And so anyway, like there's plenty that you can do there, and you can get really, really weird with it. Can the account be made dynamically? So no, accounts need to be pushed to a server. So I mean, be made dynamically. You can have a provisioner that provisions that, right? You can have a little microservice, and this is essentially what Synadia Cloud does. You have this service that like provisions an account, but the account can the account needs to be like pushed to a NAT server, so the NAT servers know about it, right? All the servers in the cluster know about it, so we need to push an account. So that's one way to do it dynamically. Now, like I think what you're asking is, if you're using something like auth callout, can you push an account and create an account and create a credential? And the answer to that's a great question. I don't know the answer to that yet. I think you can. I think you could push an account and then associate with that account to like a NATS user. And so if this thing tries to authenticate, and the server is like, oh, okay, cool, I'm gonna like call out to this service over here, and that service is like, first I'll push a new account and then I'll push a new user. Or sorry, first I'll push an account, then I'll mint a user and then get back to you on it. You should try it. I haven't tried it yet. I think it's possible. It would just require like, it will require creating this provisioner. And so it'd be kind of like an extension to my my auth callout video that I was doing. But yeah. The thing that you're missing is, okay, like let's create an account and push it, and you create it similarly to a user, but this provisioner would also have to have like a signing key from the operator in order to create an account. So, yep, great question, really great question. I kind of want to play with that now. That sounds really fun. Okay, I know we got a bunch of other questions from or not a bunch, but we got a couple other updates from YouTube. Man, we're getting a lot of engagement today. Thanks for jumping in, everybody. Nate, anything that you're seeing that's kind of popping out?
No, I mean, kind of went through. I like that train of thought with Yordis and implementing that. We had a couple follow-ups from Syrenze on Twitch. Got it working with Geo-redundancy. I don't know if you saw that message.
Oh, yeah, I wanted to cover that one. So the feature I tried, here, let's see if I could show it. Feature I tried to add was basically geo-redundancy. We're already using a supercluster of NATs. Geo-redundancy when doing metrics from network elements isn't something that have been really solved using TCP. Yep. Usually you'd have to use UDP or Anycast. Yeah, so like that's one of the things that I think like NATs can kind of solve really well. It doesn't solve for that initial connection, that whole like, trying to get the, but there's also other like solutions with just DNS in general where it's not too hard. But yeah, like trying to avoid Anycast is nice, and that's something I think NATS does particularly well. And so when we're talking about geo-redundancy, we're literally just talking about, man, do I want to try to draw a map of the United States right now? Probably not. Okay, here's what I'm going to do. I'm going to say this is a server on the east or on the west coast, and this is a server on the east coast. Here's New York. Here's California. Okay, and here's like middle America, like we were just talking about, Nate. Middle America. I'm just going to say this is America. Okay, so like the cool part about geo-redundancy is like if you have a client somewhere, you can have like an supercluster. I'm going to assume all of these are clusters, right? And all these clusters are connected to each other. boop, and boop, like this. These servers are meshed with each other. And so you can use DNS to kind of resolve like geolocation, which is nice. There's also just other ways to do it. Like you could use like, I don't know, Cilium, or like depending if you're using Kubernetes, you could use some sort of service stack to kind of map these as well. But like all these clusters have their own, assume that these clusters all have their own domains maybe, where they could have like, you know, my, let's see, central dot my cluster dot service or whatever. You can call this literally whatever you want. We have central over here, we have west over here, we have east over here. And you can resolve all these by one domain, which is really nice. The cool thing about NATs is like these servers will all gossip with each other. And not only the servers, but the clusters too. And so like it's really nice because what you can do is, you know, upon initial connection, you'll have DNS kind of resolve like the initial cluster, so it get you to the closest one. So it's not going to take you here if you're on like in Middle America, it will take you here. And once you get connected to that cluster, though, this is where the magic comes in. It's like you don't have to use something like Anycast or whatever. If you're trying to talk to service A, and there's multiple service A's, it's going to find the closest one to you. And so, like, let's say there's service A is floating around here and I want to talk to them. It's not going to route to this one because that one exists on this cluster. It's going to just find the one that's on the closest cluster, which is great, which would be like this one over here. And so we get to create like the closest kind of connection between these services. And that makes for a really nice kind of like geolocation thing. So if you have all of your stuff, you know, all of your clusters like geolocated and you're deploying like services in multiple clusters, you get a lot of really nice benefits because like imagine for a second that you have a service that's trying to talk to service A, and service A exists all the way over here on the East Coast, and you're having a conversation with your operations team, and the operations team is being like, this RPC call is way too slow. And the answer could simply be, well, we'll just deploy more of the services here. Like zero configuration changes, just deploy more of them. And now NATS automatically routes it. You don't have to change any routing tables or like DNS resolution stuff. Like you just deploy more services. And so there's like a huge benefit in being able to have this like location transparency where you can simply just like deploy more services over here, deploy more services over there. It's like all the stuff that we wished like how this stuff worked in the first place. But it doesn't work like that in reality for most cases.
Yeah. I think your cluster on the left there should be west, by the way.
Oh, thank you. Yep. Wait, you don't go east to east? Yeah, there we go.
I mean, for a really long trip, maybe.
Okay. Brian says, would be cool if you allowed the client to connect to any of the 3 nodes and after that automatically detect the closest via its ping latency and then have it connect to the closest. Yeah, that would actually be pretty cool. And that's kind of like the rebalancing story. It's like not quite rebalancing, but it's like, oh, I discovered a peer that's like closer to me via ping. That would be honestly like really cool. I figure out how to do that. I know like NATS does have like, you know, failover mechanisms. Like when a server goes down, it will like, you know, move over to its next peer. But like, and we do some things like this, but we do it with streams and mirrors. So like if you have a mirror of a stream, let's say you have a stream over here, right? Boop. Oops. This is actually a really cool feature, and maybe I should cover it more in depth. But like, let's say we have a stream over here, and like this service is like trying to get at this stream, and so they have to like make a hop, you know, over to the West Coast to be able to get at it. I can create a mirror over here, and I can create a mirror over here, and NATS like clients automatically know to just like use this one for reads, which is sweet. It's so cool. Like the NATS client didn't have to change anything. Like. It's just all of a sudden it's like it's reading from here, and I just say deploy mirror, and now it's reading from here. It's like that's mind blowing to me that you could do that. I just love that feature. So that's also something that's really cool, and I could see us like doing more stuff like that in the future.
I think you touched on that in one of the Jetstream videos, like the Jetstream basics or something. I think you kind of go into that a bit.
Yeah, I did it on Synadia Cloud, and it was actually really cool. Yeah, it was in
Okay.
one of my more recent videos. Maybe it was on like streams. But yeah, and I think we'll do a more in-depth mirroring and sourcing video because that one's long overdue, and we'll cover this in more depth as well. Yeah, streams and mirrors, not to be confused with smokes and mirrors, smoke and mirrors. Wayne coming in hot. Love it. Oh, Tom, thanks for joining us. See you're here on YouTube. Back to the top about dynamic accounts. Is it possible, at least in embedded, if you implement an account resolver instead of using the standard one? I have a prototype that does yes, and so that's one other thing that you can do is like, and we don't cover this. Actually, I'm gonna pull this out as a image because it's a really good comment. Yeah, so we did talk a lot about auth callout. We talked about this idea of like a provisioner, but Tom, who's part of our community, is always doing awesome things with Nats. He says it's possible to do it with an account resolver. And so, what's an account resolver? It's not covered very much in our documentation, but it is pluggable. You can create your own account resolver. I think you have to implement it via HTTP. I haven't looked into Nat's account resolver, but there is a pluggable account resolver. So what's an account resolver? Well, remember when I said that you have to have something like push a Nats account to the server, right? Let me get an arrow. Something has to push a Nats account to the server because the Nats account at least needs to know what the public key of the server is, or the public key of the account is, as well as like any info about that account. So it's JWT and its public key. So something has to push to it. Now, if you're using like Synadia Cloud handles all of that pushing for you, right? It's going to be automatically when you save in the UI, it pushes to the NAT server. It pushes an account. I'm going to say push account, but you can actually plug in your own Nats account resolver, which is basically what the server does to like look up an account whenever it needs to, resolve a connection. And so you can also have like a service here that's just acting as a resolver for you, and this can essentially do whatever you want, and it can resolve those accounts for you. So there is ways to kind of like dynamically mint accounts that way as well, and that might be a better solution than even what I proposed.
Yeah, I like Tom's
And Tom also
follow up
says it's a
here.
lot better in embedded mode, and that
Yep.
makes a ton of sense because it's all going to be right there. So you could use standard NATs in cache mode, and then makes RPC to the embedded NAT server to get accounts. That's really cool. Actually, that would be a really sweet like follow up video. That's a really cool pattern. I love that. So yeah, Tom coming in hot with some like really good tips on how to handle some of this stuff. But I need to play with the account resolver more, especially in embedded mode. That sounds dope. And like I can see, I mean, I worry a little bit about divergence, but I feel like embedded mode kind of is a good way. It's a good substitute, at least right now, for like a plug-in system for NAT server, right? Because you can build stuff like resolvers. You could build little services that are like tied really closely to the NAT server, and you could still accept like TCP connections, but also have the you could accept TCP connections, but also have that kind of like embedded in-process connection that's super fast. So, will we have plugins for NAT server someday? I have no idea, but embedded is a good way to kind of like mock some of that out, or at least extend the functionality of NAT server without forking NATs. So, fantastic. That's such a it's a bummer to hear folks watching on YouTube. It sounds like quality is having a hard time. I'm trying to see on my end if I'm also noticing it. Yeah, we're trying out a new platform, and so if it's not looking great, that's a bummer. We might have to switch back to Restream because it was providing pretty good quality for us. But we are, if you want to join us, we are on Riverside.fm. You can find it from the Synadia website as of now, but I'll also post it in the YouTube description from here on out. That's probably going to give you the best quality, I'd say. But yeah, bummer that we are having some issues on the YouTube side.
Yeah, it
Okay,
seems like a bit rate issue.
what's that?
Seems like a bit rate issue. It's just a
Yeah,
little low somewhere in the stream
we
connection.
are simulcasting to a bunch of other places, so
Yep.
that could be the issue. Um, Okay, well, we're just about out on time, but I'm gonna try to answer a couple more. Thanks everybody again for joining us. Hopefully this new format works a bit better. But let's answer a couple more questions and then we'll hop off. Mark says, thinking about migrating some classic HTTP request reply APIs to NATS, is there any NATS native API frameworks out there? Why, yes, there is. There's the NATS service library. And so, Mark, depending on what you're using, what language you're using, you're going to have a NATS kind of service library. Feel free to jump in the chat and let me know what language you're using. I could point you in the right direction. But I'm going to say NATS service library. The TypeScript or C#. Okay, great. Yeah, so let me go into nats.js then. There should be also be one in C# as well, but just to talk about it here, it's going to be, I think it's actually going to be in nats.deno because that's where the base client is. We have Jetstream, we have the Nats base client. It should be just here in source, maybe. No, Nats base client. I think it's service. Yeah, there we go. So so you can import the service, and basically a service represents a microservice. So while you can just do plain old Nats request reply, we actually build a lot of really cool tooling around the Nats service library. And so you can do this in Go, you can do this in TypeScript, you could do this in Java, C#, Rust, I'm sure more. But yeah, and what this affords you is you can do all kinds of really neat things, like get stats on the microservice, do automatic like discovery. You can use the CLI to kind of discover all of that stuff. And this is just all kind of like conventional stuff. It's really easy to set up a microservice, give it a name, description, version, and you get a lot of like stuff out of the box: auto discovery, auto monitoring, and just a really nice kind of format for it. So I'd go check that out. It should exist on both client libraries. Yeah, it's really fun. I do have a video that covers that too. So if you go to our YouTube channel and just search microservices or search Synadia microservices on YouTube, you should be able to find it. Yeah, microservices. I think I have one that's a preview, like this modern way to build microservices is a good one, just to show you like how it kind of works. Let's see. I want to show the CLI. So I build it out in Go, and then I think I have it in the very beginning actually. Yeah, so you get stuff like this where you can get all of the stats for like your multiple instances of your microservice running. You get like discovery where you can say, hey, give me all the microservices, and it tells you like what their names are and what version they are. So like there's just like lots of cool stuff. You could put metadata on this stuff. So like what I did here is I was able to kind of put like request response structs on here and like put them in JSON schema, and that way you can kind of have like a you could build even more tooling around this, right? You could have some sort of like validation or like auto client generation based off of like live services that are in production, which I think is kind of cool. So yeah, that's the way I'd go, because you get a lot of tooling and support out of it as well. So great. Well, I think we are pretty much just at about time.
We did have a
Thanks
question
everybody
from
for joining
Tom.
us on socials, on YouTube. Nate, anything else you want to say to close out? I know I just talked a bunch.
No worries. Tom had one final question there in the YouTube chat. Is there any movement on the proto-gen to microservice? I know some prototypes, but that would be amazing.
Yeah, I'll get back to you on that. I do want to try to bring Ari, our one of our lead architects on, because I know he's been noodling on that for a bit. Obviously, there's been some other priorities. I think he's been heads down in design with this per key TTL stream stuff, but like it's definitely on our roadmap. I know in some of our internal discussions, we've been wanting to really get that right. So yeah, we'll definitely figure that out, because I want to take. I think that's the next step for the micro framework is, hey, let's do like, protobuf or some sort of auto gen for that stuff. I think it'd be really, really nice. So yeah, I know we did some prototypes around it, and I think we just need to flush it out a bit more. So all right, so I think that about does it. Thanks everybody for joining us. And we will see everybody next week, same time, same place. Join us on Riverside. Go to synadia.com, click that top banner, and sign up for a reminder. And we'll see y'all later.
See ya.